Welcome back to another episode of the unofficial Handmade Hero macOS port. My name's Ted, and I am guiding you through this. Again, our goal is my goal really is to get you up to a point where you can follow along with the series, and that's roughly around day 25. So really, we're not actually looking at doing a full shipping Mac OS platform layer. The idea is really more to be educational and to just get you to that point roughly around day 25 where you can fully follow along with the series, doing pretty much everything in the cross-platform sort of way. So that's my goal. By day 11, so on this, it says day 14, and that's kind of where we are. We've been at this for a while, probably not going at exactly the same pace as Casey because things are a little bit different on the Mac, and that's good. But this roughly goes with day 11, and so just as kind of a caveat to starting this, I would highly recommend looking at day 11 because that's really there. He does some stuff with the code on the Windows platform layer, but what's the explanation and the reasoning I think is absolutely fantastic. If you aren't super familiar with how to do API design, I would say it is probably one of the best discussions about it and one of the most kind of, in my view, rational sort of walkthroughs of how to go about it. So I very rarely see things. I actually just watched it before starting this because I was like, oh, okay, I'm going to have to talk about this. But I don't usually see things argued quite as well, especially on the internet. So I would highly recommend kind of watching that sort of before. If you're watching this right now, I would even suggest just press pause and then go watch the day 11 video because I feel like it'll give you kind of the perspective that will help you to understand kind of where we're going here. Because the thing that we're about to do falls into a very specific, shall we say, philosophical camp as to how one would architect a cross-platform video game. Or really, I suppose you could say, really any kind of cross-platform application. And so there's kind of a very specific philosophy guiding all of this. And so if you don't watch that video, you might be inclined to ask all of these questions about, okay, well, why are we doing it this way and not that way? And so I kind of don't really want to spend this particular episode, nor the ones following it, going over kind of the same explanation that Casey gives, because I feel like his explanation is way better than whatever I could do, and that whatever I say would just be like some kind of like bastardized version of it. So I would prefer just go watch day 11. In spite of the fact that it's mostly Windows code, the principles pretty much still apply. So gonna say that. But now, assuming that you're coming back and you've watched day 11, what we're actually doing here is we're doing what's called a Unity build for the game, which is to say that everything for this for the game on the Mac is actually just in one folder for the source code. So we've just got this one folder. Hang on. Just a second. So we've just got this one folder, in this Handmade folder, right? And it's got the code. And really, this code folder is actually, I could rename it something else, but this is where all the Mac stuff lives. So this is everything that's on the Mac platform layer. It includes the build script for the Mac. So if we're building on the Mac for the Mac, we're going to be in this directory, and we're going to run this build script, and it's going to use all the files in the folder, and we're actually only going to build one. So if we go back to this build script, so this is still pretty simple, and it's going to remain more or less fairly simple. If you remember what we're doing here, we're making a build directory, and then we're basically going into that build directory, and if there was an app bundle before, then we get rid of it, and then we make another app bundle, and then we include whatever kind of frameworks we need to from Apple, from Cocoa, that are just kind of like basic requirements. Like we need app kit in order to be able to put stuff in a window, say. We also need IO kit for the IO HID library, which is how we hook up a controller, right? So we need these things, like we need these services from Apple, right, in order to be able to do this. Audio Toolbox is what gives us the ability to do audio rendering with Core Audio. So we have all these services that Apple provides, right? So that's what we need. But what's interesting here, and what follows the same philosophy as Casey was talking about with the Unity build, is this one compile line. And this here is something that's not going to change, right? So we're sticking with the we're sticking with the spirit of the series, and that was my intent from the very beginning, was to not really stray from the way that Casey does things and spin off and do it my own way. The idea was to present it pretty much exactly the same way, but as if we started on a Mac instead of on a PC. And so if we're looking at this, what we've got is this single line here that's the compile line, and we include our frameworks, right, whatever, and we have our executable, fine. But this here, this OSX main file, that's it. Like that, we're not including, we're not actually compiling really any other file into the platform layer. That's pretty much everything that is on the Mac in this this build script. That part really is not going to change. And if you watch the Day 11 video, which I highly recommend and which I assume you've done, there's some very good reasoning for that. So the reasoning is more or less, we do this because it makes it extremely easy to do a port on other platforms. So on Windows, it's just one file. It's going to be the Win main file or whatever. On Linux, it's going to be just one file. On any other platform, the actual compile line of this build system it's just one file, and it's extremely simple that way. So you're not having to figure out you're not having to solve like these problems of a build system just to be able to compile a platform layer. So the philosophy behind all of this is we look at this as if the game is a service that is being provided to the operating system. Okay, and so the idea is we start the program in Mac OS, right? And what we're going to do is we're going to ask the game, hey, give me some graphics to display. Hey, give me some sound to output. The game gives that back to us on the Mac, and then what we do is we say, oh, I've got a graphics buffer. Okay, what I'm going to do is now that I've got this graphics buffer, what I'm going to do is I'm going to make a NS bitmap image. I'm going to blit it or whatever, and then what I'm going to do is I'm going to create it, and then I'm going to put it as the layer on a window, right? And so the game is like a separate thing. It's like it's a separate library, separate thing. We pass a pointer to a graphics buffer for that game over to the game library. The game library comes back and says, "Here's your graphics." And we're like, "Great, thanks for those graphics." Now Coco, why don't you put those graphics in a window? And that's really all that the platform code is responsible for doing. And you could say a similar thing for sound, and really anything else that the game provides. So that's the philosophy. The other philosophies are, Casey goes over them in some amount of detail, but I like this because it's very minimal. It requires minimal amounts of abstraction, and it very much, I think a big reason that Casey goes with this particular philosophy is because it's pretty much exactly in line with this idea of compression-oriented programming, right? This idea of we should be finding the minimum possible way of expressing exactly what the program does, exactly what the program needs to do, in all of its hairy complications and details. We shouldn't try and like pave over those complexities or make it any less hairy than it actually is. Like, we shouldn't try to create more abstractions to make it seem less hairy than it actually is. It should be as hairy as it is in the places where it needs to be that hairy. But then in the places where something where other things need to access the same thing, that's where we move things out into a different layer or create, what we call abstractions, but what are really like a function, or what he might call a compression. We're taking that and we're semantically compressing it. So we're taking something like this, deciding what pixels we're going to draw to the screen, the colors, right? The color of pixels that we're drawing to the screen. And this thing right here, this render weird gradient, right? So that is actually that's a cross-platform kind of a concept, right? Because it doesn't really matter what platform we're actually on, right? So if we're on a PC, we're going to draw the same colors. We're going to draw the same gradient. If we're on a Mac, we're going to draw the same gradient. If we're on a PlayStation, we're going to draw the same gradient. This is going to do the same thing. And so what we want to do is this thing right here is the ideal candidate for a function that we would want to move into some kind of a cross-platform layer. This is the sort of thing that we would want to elevate to this like cross-platform status. You could even say that this is like the beginning of a renderer, right? And so we want to do that in the least complicated way, in the most minimal way. And the way that we do that is if we go back down to main, we figure out, okay, well, we know that other platforms are going to call into that, right? And they're going to want to use that thing to get the graphics, or to get the buffer that we're going to put on the screen. I'm looking for it right now. Hang on just a second. Okay, so this render weird gradient, right? And so this happens. Yeah. This happens, right? So this happens just in line inside of our main running loop, right? And so this thing's running. It's drawing frames constantly, and then we come across this render weird gradient. All right. Okay. Well, everything else so far has been like pretty much platform specific, right? Like figuring out how to handle keyboard events on a Mac. But now we run into this place, and now all we do is we say, okay, well, we're looking at this as if the platform, the Mac, is going to ask the game. So the game, remember, the game's providing a service to the platform. the game is giving us a display buffer. Okay, so what we're gonna do is we're gonna okay game, give us the stuff that's in the display buffer on the screen. We're gonna pass you a pointer to that buffer. You're gonna fill it up. And we're gonna pass you an X offset and a Y offset, and you're just gonna go to town and you're gonna give us a buffer back. And then what we're gonna do is we're gonna take that buffer, so this redraw buffer. So we're gonna send you a pointer to the buffer. You're gonna fill it up. We're gonna get it back. And then what we're going to do is we're going to take that thing and we're going to put it in a window. And that's the kind of responsibility that a platform layer should have. It should be doing that, and really no more than that. I guess I don't really want to sound too dogmatic. Like I say this as like we're doing it this way because this is the most in the spirit of Handmade Hero, and I don't necessarily want to say that you have to do things one way or another, or that my way is the best way, or that like this way of programming is the best way. Really, go and try and program a lot of different ways, and if you find that those ways of programming are most productive for you, then do those. So really, I arrive at a lot of similar places, just I think through experience and through having done this like really kind of like over abstraction sort of thing, and so like I know where that goes, and I've arrived, I've been in that place, but some other people may find that productive, and so it's really I don't like ever telling people like you have to do it this way. I would much rather people just I'm empirically minded. You should discover what works for you. So, but I just kind of want to say like this is the philosophy. So the philosophy is we're passing a pointer to this buffer, and we're going to fill it up, and then the game is providing this service to the platform layer, and then the platform layer's only responsibility is to do Mac specific things, is to take what the game gives it and make sure it gets routed to the appropriate channels. So take this display buffer, make sure it goes to the window. Later on, it's going to be doing that same thing, but maybe what it needs to do is like figure out how to set up metal, right? So it's still going to be getting like textures and maybe like vertices and all this other stuff from the game. But then what it's going to do is it's going to take those textures and vertices and bitmaps and sounds and all this stuff, and it's going to figure out how to get those things to the appropriate places on the Mac, right? And so what I like about this also is, again, not saying anyone has to do it, but if we do it this way, we have very minimal code changes, and things stay pretty much as they are, except all we're doing is we're like moving some functions to a different place. Right, so everything stays in line exactly as we had it working. Doesn't really move around. I can still open up this platform layer and follow the code from the start of main all the way through to the end of the application. So I can follow it very logically and understand exactly what got created where and what's calling what and how things are getting passed around. So none of that changes. All that changes is we're starting to figure out what stuff truly is cross-platform, or what stuff do we plan to have as cross-platform, and where are we going to move it, right? And so what we're going to do is we're actually going to move this over to a cross-platform game library. So let's see. So I need to get out of that directory. And so I'm just, I don't usually do this that's the build. I forget my ordering of stuff that I usually have. So I have it, because now we're actually getting into by day 11. Okay, so I need to get in the Handmade directory. So I'm just going to go into the Handmade directory, and then now what we're going to do is we're just going to make a CPP folder. And that is actually going to be the start of the cross-platform code. So, oh, oops. I have to do, if I do it from Vim, I have to do like a exclamation point. So CPP, and then just go into the CPP, and then code. Okay. Okay. And what we'll want to do is we'll want to, we don't even need to have a handmade.h or anything like that, a header file yet. We're actually just going to include the CPP file like right in there, right in our platform layer. So we're kind of just starting the process of moving things. Really, in this video, all we're going to do is we're just going to move the graphics out into the platform layer. So in that case, let's see, I can go Tab E. So this is, if you're using Vim, Tab E will create a new tab, and then it will do that with whatever file you do. So we're going to call it handmade.cpp. And now handmade.cpp is the primary entry point into the, or rather, it's where we're going to be hosting all of our non-platform specific code. So this is really the game library. So in other projects that I do, I just call this like, game library or whatever. So whatever you want to call it, but in this case, it's it's handmade CPP. This is kind of the starting point. We'll sort of move files in other places kind of as we go, but that's what it's going to be. Okay, so we've got this handmade CPP, and really all we're going to do right now is we're going to move this. We're going to move this render weird gradient, and so we're going to move that. And I think we're just like, let's rename it something else as well. I think if we call it, just call it like game update and render. That's what Casey calls it. So we got this, and there's a few things too that that are gonna. So another thing too that's kind of like a to-do. Pass in the endianness for the platform. So that's actually going to be really important. So the display buffer on the Mac is a little bit different from what it is on Windows, and so the code is not exactly the same here, just with the way that the pixels are laid out. And so that's kind of important to note. It's not a killer. It's like there's a it arguably is it's a part of this that is not really cross-platform, but it's pretty easy to just like pass a flag in. So you can imagine if we just like pass like some extra flag in that's like, hey, is this kind of endianness or whatever, like some sort of system where we just pass a thing in where we can just check, okay, if it's this endianness, then use this pixel order. If it's that endianness, use that pixel order. And that's more like, it's kind of like the buffer specific. But aside from that one thing, like, this is pretty darn cross-platform. So it's a bit of an annoying thing, but it's certainly not really a killer. And so anyway, and I have that as a to-do because I really don't want this to be about. I want the interface to be like roughly as close to the Handmade Hero series as it can be, and so having to pass in like extra endianness flags, like I feel like too early on, that's kind of like diverging from the purpose of it. So I don't really want to do that yet. It's just like later on, it probably would make sense to do that, because even his, like, if you look at it, his handmade file. The way that it handles drawing is not actually cross-platform, right? Because other platforms are going to have buffers that have like different endiannesses for the individual pixels. So, that's something his thing doesn't take care of, and so there's it retains a little bit of like platform specificity in it, even though most of it's cross-platform. So already one thing that you'll note is the first parameter that's in here, this Mac off-screen buffer, right? So that thing, remember, if we're actually in a cross-platform game, we really want that to be, we want that to not be a concept in the cross-platform code. And so we already know, like, automatically that this needs to change, just because we're seeing that. You know, we're seeing here, like, this is not really something that, so we want something that is like the Mac off-screen buffer, retains all of the same qualities of it, but just has probably different naming. So we'll call it something like, let's call it just game off-screen buffer, right? And it's got, and you know, in all likelihood, we'll actually end up getting rid of the Mac off-screen buffer, because what we'll do is we'll just have the Mac platform layer just create a game off-screen buffer. Like, there's nothing really platform specific about, you know, the off-screen buffer that's like on the Mac that says that it has to be defined on that platform. So do that, and then we're going to go back up to our platform layer, and I think, let's see, yeah. So this thing right here, right? So width, height, by, okay, right? And so all we're going to do is we're just going to like say, okay, great. It's pretty much the same concept, right? It's got some memory. It's got, you know, all this stuff. So, and I think we'll just get rid of this concept. We'll just nuke that concept entirely, because that's not really something that's specific to the Mac. That's something that's actually kind of a cross-platform thing. So we've got that. I'm just kind of going back here. So there's all of those things. Now what we're going to do is we need to include this. And so we've got, got the offset X. So we just want to include this in our main file right here. So we're just going to do include, I think it's // I forget. I want to say that's right. Super B code. Okay. So we're just going to straight up include that right after we include the main header file. And actually, we also have a few other files that need to move. So we'll move those at some point. But you'll notice that now we've got this like Mac off-screen buffer. Okay. Yeah. So what we want to do is we want to just kind of replace this Mac off-screen buffer concept with the game off-screen buffer concept first. So kind of a little trick that I do in Vim is I go, so I'm in the command line right now for down at the bottom. You can probably see it. So I just go %s Mac off-screen buffer / game off-screen buffer / G. So G is just like global replace. What it means is if you don't do the G, then it'll only do like the first occurrence of it on one line. If you do the G, it just like does all of them. So now we've effectively replaced Mac off-screen buffer with game off-screen buffer, right? Okay, so that is going to take a game off-screen buffer. This thing also takes a game off-screen buffer. Remember, we've pretty much just renamed the structure. There's really like nothing different there. So this is the initializer for the off-screen buffer. All right, and let's see. I think we just need. We have to change the name of the. Okay, so that's the refresh buffer. Yeah, so render weird gradient. We've decided that we're going to call that something else. We're calling that game update and render instead. Game update and render. Okay, so game update and render, that just same function. That function should be available now to us because it's defined in this handmade.cpp file. And all that's going on is, so we don't want to pass a Mac off-screen buffer, we want to pass a game off-screen buffer. And so we'll do that. So we pass game off-screen buffer, and then it's just going to do pretty much the same thing here. So we're at day 14. So I'm going to try and build this. It's probably going to be something broken, I'm guessing. File not found. Okay. Of course. What did I do wrong here? Let's see. I know I've got a version that's working, so I'm sure that I know I've got it in my following Handmade Hero. So I think on day 11 I have that. Oh, okay, /cpp. Okay, got it. And I'm sure there's going to be some problems, so let's figure it out. Okay, so yeah, I guess I didn't need the Handmade folder, right? CPP code, okay. So couldn't find that. All right, and that builds. And so it's probably would be incumbent upon us to see if that gave us the result that we want. So let's take a look at that. Yep. So that's our same thing. Obviously, we only touched the graphics. We haven't really touched the sound yet, and we'll get to that. So kind of moving the buffer around just as normal. And remember, the only difference is we moved some files, right? So that's all that we did is we. So let's see. Yeah. So obviously I could cross-platform game library. Right. And these files actually, I'm not going to include them in the so this handmade.cpp. I'll show it in the video, but really I don't want to get too far into copyright issues or anything like that. And again, my goal is not to really do everything that Casey's doing. My goal here is to just get people who are on a Mac up to speed, give them something they can kind of follow along with, because I know for me it was really daunting at first. There was a lot to learn, and I'm really just trying to solve my own problem, because the problem I had was there weren't many really great resources. It seemed like everybody was kind of doing their own thing, and not a lot of people were actually really trying to follow along in the true spirit. And so what I wanted to do was make something that if you started from day one with the video series, you could just literally follow along with the exact code changes. But we're actually, now we're starting to get into a certain kind of territory where, the stuff that's in this file is, considered cross-platform. It's considered, part of the game library. It's considered not really in the platform layer. And so I'm not going to include this bit of code in the actual source code repository. So from this day forward, what you'll have to do is you'll have to copy your own code, or copy code. Go and purchase the game. Go to handmadehero.org and buy the game, and then you'll get access to all the source code. This code here roughly parallels day 11. So if you're on day 11, then you should be able to just see a file that's called handmade.cpp, and you should be able to just grab this, right? But I'm not going to put this on any kind of source control repository, because it's violating copyright. I feel like it would be disrespectful as well, and frankly, I want to give people kind of an impetus to just support the series. So that's that. So notice that we're just straight up including this for now. There's nothing all that special about what we're doing here. I do want to. I'll give you a bit of a preview into what we'll start doing later. Um, but yeah, right now, like, there's nothing super official about it. Like, we haven't, done some like magic, like, here's our game, and like we haven't created this like heavy concept yet. And the reason, or heavy abstraction or anything like that, the reason is because right now we are just, all we're doing is we're asking ourselves like a more simple question, like, what is the cross-platform stuff that this thing does right now? And yeah, later on it will do other cross-platform stuff. But right now, all it does is this one thing. And so all we need is this one file. All we need to do is start moving over the services that the game provides to the platform layer into into this one file, into these functions, with very minimal abstraction, with like the least amount of possible abstraction possible. to sort of like, repeat myself over and over again. So that's that. And then I've also kind of noticed that there's another file that we sort of probably want to lift. So yeah, I know, using mouse cursor. So we probably want to move these handmade types, right? So handmade types, that's a pretty cross-platform concept as well. So I'm going to open that up just to kind of give you some sense of what that is. So if you think about that, this stuff is going to be, we're going to see this on like every platform, right? So we're going to see, Casey does this like just kind of using these different kind of names for static so that it's more kind of clear what the intended use is. And we've also got these, these different type defs for all, just kind of, so we don't have to do like, int8_t. So we've got all these, but this is a totally cross-platform concept. This is something that doesn't really care if we're a Mac or we're a PC or we're a PlayStation or a Raspberry Pi or anything. This is also a cross-platform concept, and so we should really, move it into the part of the app that we're starting to consider to be the cross-platform thing. So that's the thinking. So we're going to do that. Okay. So that's moved. And then I think this obviously won't build now because we moved it. I think OSX main calls it. And so I think it's all we got to do is just do this like .. CPP code. Right. And then build. Okay, so that's going to be pretty much the same. We can run again just to make sure that that is what we wanted. That sounds like it's too fun. This, I have to admit, my second iteration of this, like, the first time I tried to do this like weird oscillating sound thing was kind of crappy, but my second iteration, I've really improved my. so that's much better. All right, so we've, is everything right now that can be cross-platform? Absolutely not, but we're kind of starting down that path. So we've decided to replace this Mac off-screen buffer with a game off-screen buffer kind of a concept. Pass that over to the game. That's really the only thing that the game cares about. We may end up having some platform-specific stuff with respect to display that we would maybe move into like a separate structure, maybe. But for now, there's like there's a one-to-one mapping, between the display buffer that we create and what we pass over to the game. So there's really no need to do anything there. So we're going to keep that the same. And let's see where. So the next thing, obviously, there's a few more things. Next that Casey does is sound. So we're going to do sound next in a different video. And we're also going to do controller input. I wanted to give you a sense of sort of where this goes. So just as kind of like a bit of a preview, I actually ended up making kind of a so I've started kind of on a game just to see what that's on my own game, just to see what that's like. But what I did is I later on, so actually I've got all kinds of things that are not great about it, but I'll just show you right away anyway. So I've got like I've started on a 2D platformer. A lot of it's based on stuff that I learned in Handmade Hero. Not really sure what it's going to be, but so Mac platform layer or code. So I named the different folders a little. I named the folders a little bit differently, and so now I'm just going to do this and then build it. Okay, hope there's some stuff that's right. All right, so that's all being built. What I want to do is show you some of the stuff that later on. So first of all, what is this game? Right now, not much. It's I'll play it for a little bit, but see how I've got this. Like what I've got is just I've just got kind of like a tile map, a little world, a square. So I figured out how to program like variable jump and physics in. So just for any of you that are watching this and wondering, okay, well, what, once I start kind of watching the series, when will I actually get to make games? Well, here's an answer, is like I got to about day 50, and so I took all the stuff that I learned and I was like, oh, okay, well, let's figure out something that we can do here. And so I use kind of like this collision mechanics. A lot of this stuff I built myself. So the concept of a jump, I figured out how to do that. But it's based off the same platform layer. It's based off of all the building blocks that you're learning here. So it's based off the same kind of cross-platform thing. So I figured, for this video, like, I'm not going to be as good at, explaining the why of, a particular approach to kind of cross-platform, game design or like game architecture. But I can kind of show you where this is going on the Mac, because this game is actually still cross-platform. So this same library, you could call into it from Windows if you wanted to. You could easily build a platform layer around it. Yeah, I use a lot of the similar code as Casey, and I certainly have been doing that. But all of this, there's no reason that couldn't be, that Windows couldn't call into it. It's got another, like, some kind of cool properties as well. So some of the stuff that one thing that you can do. Let's see. So actually what I want to show you, kind of while we have some time, is sort of where this goes. But notice that the build script, right? So the build script gets a little bit more complicated, right? We've got, okay, so we're putting, I'm throwing some stuff over the GPU, fine, right? So I'm doing some stuff with metal so that I can get faster frame rates. But the core concept is still the same. Like, the game library gives me back a display buffer, and then the only difference is how that's being blitted or drawn to the screen. It's just that I'm using Apple's Metal framework instead of the other kind of like software renderer, more expensive thing that I was doing. So this is just to give you a sense. So maybe I pulled out a few of these things that are kind of used in building, but aside from that, like much of it's the same. The big thing to notice is that there's only 2 compile lines in this entire thing, right? So there's one compile line for this would be the Mac platform layer, right here. Okay, so that's compiling the platform layer. But then what we also have is we've got this compile line for the game library. And this is something that you'll see later on. The way that this build system is set up, and the way that we'll eventually architect the platform layer, is such that I can be playing this game and making changes to the code So I can be making changes to the code and then recompile it as I'm playing the game and then have it get hot loaded. So check this out. Because it's sort of like impossible to believe until you so if I go into my game library and so first of all, like, let's say I'm running this thing. So like I'm gonna run it now. I'm gonna run my platformer game, right? And let's say that I want to I don't know, like let's say I've got my oops. Yeah. I've got some I don't know. So one thing I could do is I could this is like controls like the jump velocity. So like right now if I'm playing, right? So my max, I give them like 30 units of velocity as kind of like the max jump speed. To do variable, it's a little like, so this, I try to kind of do like replicate like Mario's jump. That's a little bit more of a complicated thing because what you want to do is you want to like kill his velocity when you like let up on the X button. That's a bit different, but you can see that I get to about this height, right? So I get to about kind of underneath that block, right? Well, so one thing that this build system and this particular kind of architecture will give you, if you follow along, is the ability for me to go, okay, well, you know what, screw it. I don't want 30, I want like 40 instead, right? And so I'll save that, and then I'll just build again, right? And now like my game, mind you, is still running, okay? Still running. I didn't close it. And now I'm jumping, and now I'm jumping way higher than I was, right? There's other things that this allows me to do. So I've also, you end up building like a looped code editing thing. So I'm gonna put it into recording mode. Okay, so now I'm jumping around doing all this stuff. And I'm gonna end recording mode. And so now what you've got this playback going on. And now what I can do is I can go into my code and I can tweak the code. I can say, okay, well, screw that. I'm going to, oops, not that much. I'm going to go back to like 30, okay? So let's do that. And let's build this thing, all right? Okay. And now, remember, I'm actually just playing I'm playing back a recording of my input, right? And it's without ever reloading the game. We've got this guy jumping a little bit lower at the old jump rate. So you can imagine how freaking cool this is because there's all this stuff that we had to do without, you know. So, you know, people talk about, oh, you need to make a scripting language, you need to do all these things in order to be able to do it. It's like, no. Actually, what I'm trying to sell you on here is if you architect things a certain way, some things are going to be really, really easy to do. And in this case, having this very clean distinction, or rather, viewing the game as a service that is provided to a platform gives you the ability to do really cool things like this. Because we make the game library as this separate thing that the Mac platform layer then can like hot load whenever it wants to. And so I can make changes to the game library and the Mac platform layer can be listening for those changes and it can just load it like that. It's pretty cool. Pretty cool. So you know, again, you know, you don't have to program this way, but it leads to some pretty neat results. So that's kind of my spiel on that, and it's all retains the same level of simplicity because if you wanted to, you know, produce the same game on a different platform, in terms of just the compile, sure, we do all these other things. Like there's other things that we have to do on the Mac, right, to get that. Especially to get this kind of like working on a GPU and to get it doing certain things. Like we have to, you know, include metal and we have to like, you know, we have to like embed a metal library in there. On the Mac, like there's this very, Mac OS is like really specific about apps being like sandboxed and like never touching files or like not touching like memory outside of that sandbox. And so you've got all these lines about, so all these like CP or like copy lines, it's pretty much just like get things into the bundle directory so that if the app ever needs to, or the game needs to like touch the file system, it's touching acceptable space that where the operating system's not going to trigger an exception or kill it. So these are all things that that are a required part of the Mac platform, sure. But when it comes down to actually doing the compile, that part, the code part, just these 2 lines. That's it. So there's some simplicity, some elegance to it. Anyway, just thought I'd show you some of the places that you can go with this, because it's really some rather powerful stuff that you're not going to quite understand how cool it is until you push past the learning curve. So that's that. I feel like I've covered everything. Again, if you have not watched Day 11 of Handmade Hero before watching this, you should just watch Day 11, because Day 11 is freaking fantastic. There's a lot of really solid explanations for how you might go about doing a cross-platform game. There's a lot of explorations of different ways that you could do it, along with kind of the reasonings as to what are some of the advantages or disadvantages. It's a much better explanation than what I can provide. I'm just showing you that he does it on the PC in the series, but you can absolutely, and I have, you can do this on the Mac as well, and it's pretty neat. So that's my spiel. See, tomorrow I think we're going to start on cross-platform sound. So we're going to start moving sound output over to the game library. That's going to be pretty similar, and yeah, we'll just kind of keep going from there until we hit roughly day 25. And then I'm going to say I'm done with the project at that point, and I'll probably move on to some other stuff. So I will see you later.